So let's talk about the equation of the line from the beginning, right? Do you remember what was the equation of the line? This is y is equal to the kx plus b, right? If you're given a line in the two-dimensional coordinate system, right, you can define the line using this equation, right? For example, there is a line and its equation is equal to the y is equal to the kx plus b, okay? Now let's go to these three-dimensional case. X, y, and z. And let's say we're given some line, okay? And I would like to define this equation. So I can't define the equation of this line with this equation, y is equal to the kx plus b anymore, because I have the third component z, right? So we need to figure out another way of defining the line, right? And one of the ways of defining the line would be vectors, okay? So do you remember yesterday we talked about the similarities of the vectors and the points, right? So we say that, hey, one point here, P, was the components x0, y0, z0, can be written just a P, x0, y0, and z0. And we can define a vector also using the three components of the same point, right? So we can define a vector U is equal to the x0, y0, and z0, okay? So this vector is going to be a vector which is starting from the origin and which is looking to the, which is going to the point, right? Which is going to this point. Okay? So the idea of constructing this line in the 3D or in higher dimensionalities would be define the points on the line using the vectors. Okay? Basically, I would like to get the equation of this line, the vector equation of this line, so that I can define all the points on this line using the vectors only. Okay? Is it clear what is the motivation to do this? Okay? So we can't define this line using the previous equation, y is equal to the kx plus b anymore. Okay? So the idea is we would like to define the lines in any higher dimensionalities, more than 2, more than 3, 4, 5, and so on. Okay? So what is given is for us, so let's say we're given a line and we're given some point on this line. Okay? We're given some point on this line and we're given a vector which is parallel to this line. Okay? Two things which are given here. So we're given some vector u which is parallel to this line, and we're given some point on this line. We need to construct a general equation of this line. So let us write this. Given if vector u was the components, let's say x0, y0, and z, where A, B, and C, A, B, and C on the line, and point P0 was the components x0, y0, and z0 on the line. Okay? So I would like to find the coordinates of one of the points, for example, this point, P was the coordinates x, y, and z. Basically, if I can find the coordinates of all the points using some rules, using some equation, it means that this is the equation of the line, right? So let's choose one of the points, any point on this line, with the coordinates x, y, and z. So I would like to find its coordinates. What is the x, what is the y, and what is the z? Okay? So how it is possible to obtain this? So you're given one vector u on the line and 2 points on this line. How to find the coordinates of the point? Basically, let me draw this one more time. This is the line. You're given one vector u. Okay? Then all at the same time, you're given a point P0 and you're given a point P. You would like to find the coordinates of the P. So you're given a vector, point P0, and you would like to find the coordinates of this P. So what kind of equation, what kind of rule we can create here? So if I make the vector from P0 to the P, right? Let's make a vector. So let's make a vector which is going from P0 to the P. Okay? This is going to be a vector. So how we can connect this vector U with this vector P0 and P? What is there? Are there any connection between them? They are parallel, right? So how we can obtain the vector P0 and P using the U? By multiplying this to some constant, right? So we can obtain this vector by multiplying the U to some constant T. Okay, this is going to be P and P0, P. Okay, so do you remember how we define the position vector if we're given a vector using the T points? By subtracting the P0 from the P, right? If you would subtract the P0 from the P, this is going to be like this. Okay, here we're going to consider them as the points, as the vectors. Okay, so that is why the components of the vector or the points of the P, which is x, y, and z, is going to be equal to the components of the P0, x0, y0, and z0, plus T multiplied to the U with the components A, B, and C. This is the equation of the line. This is the vector equation of the line. Okay? Let's do an exercise in order to understand what does it mean. So let's do an exercise. So let's say we are given a line, and we know the point on this line was the components 5, 1, and 3. And at the same time, we know that this line is parallel to the vector V, or U, with the components 1, 4, and minus 2. We need to create the equation of the line. Okay? So this line is parallel to some vector U. Okay? This line is parallel to the vector U. And also we know the point on this U, on this line. Okay? P0. So in order to construct the equation of the line, we're going to write this. So x, y, and z component of the points on this line is going to be equal to the P0, right? Plus T multiplied to the U. This is going to be equal to 5, 1, and 3, plus T multiplied to the 1, 4, and minus 2. Okay? Or you can write this down in the form 1T plus 5, right? The vector operation. When you multiply a constant to the vector, it is going to be multiplied to all the components. And when you add the vector T vectors, you're going to add the components correspondingly, right? It is going to be T plus 5, 4T plus 1, minus 2T plus 3, right? X, Y, and Z components of the points on this line can be found using this equation. T plus 5, 4T plus 1, minus 2T plus 3. This is similar to the parametric equation, right? So X component of the line can be found using T plus 5. Y component can be found using 4T plus 1. And Z component can be found minus 2T plus 3, right? For example, we can find a couple of points on this line. By setting T to be equal to the 0, we can find the P0, right? If you set T to be equal to the 0, what is going to be the point? X is equal to the 5, Y is equal to the 1, Z is equal to the 3. This is exactly the coordinates of the P0, right? If you set up to be equal, T to be equal to the 1, you can find another point on this line. It is going to be X to be equal to the 6, Y is going to be equal to the 5, and Z is going to be equal to the 1. This is another point on this line. Okay? So this equation is called the vector equation of the line. Vector equation of the line. So when you write down the equation component-wise, like x is equal to the first component, y is equal to the second component, and z is equal to the third component of this right-hand side part, this kind of equation is called the parametric equation. Parametric equation, where t is going to be equal to some parameter. T is called some parameter. Okay? So at the same time, we can obtain another type of equation, which is going to be called a symmetric equation. Okay? So if we're given a u vector, which is parallel to the line, and some point P0 with the coordinates x0, y0, and z0, then the equation x minus x0 divided to the a is equal to the y minus y0 divided to the b is equal to the z minus z0 divided to the c is called symmetric equation of a line. So let's do an exercise. So let's say we're given 2 points on the line, okay? So A and B was the coordinates 2, 4, minus 3, and 3, minus 1, and 1. So what you need to do is you need to find the vector equation in the symmetric equation of this line. Okay? So how to do this? Okay, so let's say you're given some line and you're given 2 points on this, A and B. Okay? A is going to have the components 2, 4, and minus 3, and B has the components 3, minus 1, and 1. Okay? What we want is we would like to build a line, right? Previously we said if I would like to build a line, the equation of the line, we need 1 point and 1 vector, right, on this line. So, but now we're given 2 points. How it is possible to find the equation of the line? Yeah, actually, we can build a vector, right, which is going from A to the B. Then we'll have 1 point or this point. It doesn't matter which point you're going to choose in one vector, right? So the vector on the line is going to be this vector, right? AB vector. And a point on the line is going to be just A, right? And you can reach any point on this line by just scaling this vector, right? For example, you can reach some point C here by just making this vector smaller, right? Or you can reach another point here, D, by just making this vector longer, okay? So the vector AB is equal to subtraction of the A from the B. This is going to be equal to the 3 minus 1 and 1 minus 2, 4, minus 3, right? So this is going to be equal to the 1 minus 5 and 4. This is going to be our U vector in our formula, okay? And just choose P0 as one of the points. For example, you can choose this as A or as B. You're going to have the same equation, okay? You can choose this as A, and this is going to be equal to the components 2, 4, and minus 3. Then the parametric equation, or the vector equation of the line, is going to be x, y, and z components of the points on this line is going to be equal to the P0, right? 2, 4, minus 3, plus t multiplied to the u, which is 1, minus 5, and 4, right? Or the symmetric equation is going to be x minus x0, which is t, divided to the a, which is 1, is equal to the y minus y0, which is 4, right? This is x0, y0, and z0. 4 divided to the b, this is b, right? Minus 5 is equal to the z minus 3, which is plus 3 divided to the 4, is the symmetric equation of this line.